Hello everyone, welcome back to the channel. So today's LeetCode problem is 1559, detect cycle in a 2D graph. It has been marked medium on LeetCode. Let's go through the problem statement. So we have been given a characters array, a 2D characters array, and what we need to find is there a cycle formed using a same character? Which means if we start from this A character, is there any path or traversing through which we can reach this A again? If you can see this, if we go through this path, we are reaching A again. So the cycle is detected here. If no cycle is detected, we just need to return false. The allowed direction is up, right, down, and left. So before solving this problem, let's see the pattern where this problem falls in. So whenever you see a grid and you have to move in 4 directions and the cells are connected and you have to detect the cycle or something. So basically when you see a connected components are being formed like this in the graph, just think it is a graph question. So the each cell will act as a node, the each edge will be the neighbors, and you just need to detect a cycle. So we can use the basic logic of detecting a cycle in a graph. What is a cycle in a graph? A cycle in a graph is basically if we start a path from the node and we are returning to that path, that node again using some other path, it forms a cycle. You can see the algorithm is basic. We will apply basic DFS for finding the cycle. So what we'll do, we'll maintain a visited array and we'll apply DFS at all the cells which are not visited. And if any cell is visited and we find that it is not the parent cell, so we detect a cycle. We just return to try run this problem. So as we discussed, we are applying DFS here. So the parameters we are taking in this DFS are the current cells row and column and the parent cells row and column from where this current cell we are reaching. Why are we keeping this parent cells row and column? You will exactly know till the end of this drive. Let's start our path from this A, which is at 0, 0. So first what we'll do, we'll just mark it as visited and then call for the next DFS for 0, 1 when where the parent cells are 0, 0. Mark it as visited, call for 0, 2, parent as 0, 1. Mark this as visited, call for this A. DFS for will mark this as true, call for the DFS for 2, 2, mark it as true, call for the DFS of 2, 1, mark it as true, call for the DFS of 2, 0, mark it as true. Okay, so now at this cell 1, 0, we'll just mark it as true, and then the paths we can explore are up, down, left, and right. So down is not allowed because it is the parent cell. So this is the exact significance of keeping the parent, that we should not backtrack to the parent cell because they are already visited. And so from here we can go left, we can't go right because there is B. We are exploring the path with the same characters. So one option is only going up, and we can see that it is already visited. So this detects a cycle. Basically what we have done is we have visited all the cells with the same characters, and we have find the path that we are reaching the same character again using a different path, not just the backtrack solution, and where the parent from the parent cells are different. So there exists a cycle. So we'll just return it true. Okay, let's go through the pseudocode. So our core idea was to apply DFS for every cell because graph can have multiple components. So there can be multiple disconnected components, and the cycle can exist in this component or this component. So we have to explore all the cells. So in the first step, we are just taking the visited array, and then we are just iterating over all the cells, and if they are not visited, we are just applying the DFS and taking the parameters I, j, parent of I and parent of j. In the first iteration in our example, the DFS will be the parameters will be 0, 0, parent of I will be -1 and parent of j will be -1 because we are just starting, there are no exploration built in. Okay, in this DFS function the first step we are doing is we are just permanently marking the current cell as to visited. So if we are visiting 0, 0, we will make the visited of 0, 0 as true. The next step what we are doing is we are exploring all the 4 directions. For the directions I have taken dx and dy. So this will help you to move up, down, left and right. Okay, from this we are calculating the new I and new j which we need to explore. Now suppose if the ni and nj are out of bound, means if you are at a at 0, 0 and you go left, it will be out of bound, so we need to skip this thing. If there is a different character, suppose from this A you are visiting, you are trying to go right, you will encounter a B. Now we don't need a path which have different characters, right? So we'll skip this. Now suppose if the visited of Ni and J is true and it's not the parent, so we'll just return a true that the cycle is formed. Consider this case. We have explored using all these things, and we have reached 1 comma 0. Now from 1 comma 0 we are going to 0 comma 0. The Ni and Nj is 0 comma 0. Now at this 0 comma 0 will be already visited, and the parents for 1 comma 0 will be 2 comma 0, not 0 comma 0. So the parent is different and the visited is true, means the cycle is detected. If everything is not possible, we'll just see if the visited is false, and then we'll call for the DFS of that. Let's discuss the time complexity. So time complexity will be order of m cross n, because we are visiting every cell in the grid only once, and the space complexity will be order of m cross n because we have a visited array that we carry. So the takeaway from this question is, if you recognize this pattern, cycle direction, graph, DFS, and you encounter similar problem in an interview, you can easily solve.
So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD, or GenAI, please follow along. The code will be given in the description. Thanks.